So let's step back and suppose that you are a sociologist and you want to study income inequality in the United States. And in particular, you have a data set of the income distribution of Americans who are 18 years and older. You do know that the United States has a high level of income inequality, but you want to do further research. And so you have this data set, and sort of one way to really begin is to calculate measures of central tendency. So what is the sort of typical income in the United States? And this is a recent data set, an actual set of data on adults in the United States. In this data set, we simply have two columns, two variables. The first column is income. So this is the personal income in US dollars in this sample of Americans. And then we have age in years. And you can see that we have, in this sort of data set, we have about 1,000 people in this data set. Right? For income, if we calculate the mean and the median using statistical software, the average income in this data set is about 37,000 US dollars. The median is about $23,000. So you can see the median is a little bit lower than the mean. So what this should suggest to you is that there's some set of values, some set of extreme values that are pulling out that mean relative to the median. The mean is being pulled upward because of some extreme values in the data set. A handful of people have a ton of money. That's basically what's going on. So sometimes when you hear in the news or in the media, when people talk about the median income, they're reporting the median income rather than the mean income, because it's commonly thought that if you just report the mean income as a measure of the typical income of an adult in the United States, that's misleading, because as a measure of central tendency, that's being pulled upward by the relatively small number of people who have a ton of money. So the median income is typically reported if you want a sort of snapshot summary of the center part of the income distribution. So you have an idea, based on this sort of analysis so far, of what the typical income is in your data set. But you might ask, well, we're just looking at the center part of this distribution, of this numerical variable. What's the income for the very rich, for the top 1%? What's sort of the income for the bottom 1%? So if you look at the tails of this distribution, how much money are they making? Well, this requires a different measure of location than just these measures of central tendency. In order to really locate other values in our distribution, we introduce the concept of percentiles. A percentile is simply the value below which a percentage of the data lies or falls. So for example, if people talk about the 30th percentile, that's the value below which 30% of the observations may be found. So 30th percentile, 30% of the observations lie below that. The 50th percentile, the median, 50% of the data lie below that value. That's simply what a percentile is. It's a measure of location or position of a variable's values. And you hear percentiles used all the time. I should mention that sometimes if you calculate percentiles by hand, it can get a little bit tricky. So for this course, and in general when you do data analysis, most people calculate percentiles using statistical software. A related concept to percentiles is quartiles. So here's a number line marking different percentiles. We have the 0th percentile, the 25th percentile, 50th percentile, the 75th percentile, and the 100th percentile. These percentiles just indicate the percentage of the data that lie below a certain value. So the 50th percentile, 50% of the data lie below that value. It's sometimes useful to distinguish certain kinds of percentiles that we call quartiles. So those are simply percentiles that are quartiles. So the 25th percentile is the first quartile. If you divide a distribution into 4 parts, you have these different quartiles. You have these 3 quartiles. So the first quartile is the 25th percentile. The second quartile is the 50th percentile, or the median. And the 75th percentile is the third quartile. So, for example, the 75th percentile, the third quartile, that's just telling you that 75% of the observations lie below the value associated with that quartile. And so I've labeled it here. Now, the different quartiles. One sort of point that you should keep in mind is that the median is the same as the 50th percentile, which is the same as the second quartile. Those three terms mean the same thing. Now, sometimes you'll also see a reference to the fourth quartile and the quartile 0. Those are simply the 0th percentile and the 100th percentile, respectively. So quartile 0 is the 0th percentile, quartile 4 is the 100th percentile. Right? Sometimes you'll see reference to that. There are also other names for quartiles that you might encounter. So sometimes the 25th percentile is also called the lower quartile, and the 50th percentile is called the median, as I just mentioned, and the 75th percentile is sometimes called the upper quartile. So if somebody's telling you, I looked at the value of the lower quartile and the value of the upper quartile, what they're really talking about is the 25th and the 75th percentile, right? And I've labeled it here. Again, this is just all terminology. It all means the same thing. The whole point about quartiles is that often it's useful to not talk about specific percentiles, but to look at bigger chunks. And these bigger chunks of our distribution we call quartiles. So let's look at our income data. We already looked at the measure of central tendency in terms of the mean and the median, or the 50th percentile. Well, let's think about the top 1%, the bottom 1%. So if we, and then other quartiles as well. So if we look at these different quartiles, you can see the first quartile is about $8,600. That means 25% of our observations, 25% of people in our data set lie below $8,600. To put it another way, about 25% of adult Americans make less than $8,600 each year. The second quartile is the same as the median. So that is $23,000. So about half of adult Americans above the age 18 make less than $23,000 each year. The third quartile, the 75th percentile, is $48,000. So that means 75% of Americans make less than $48,000 each year. So you can see that we're getting an understanding of about sort of the overall distribution in terms of income in the United States. But we might also want to look at specific percentiles, smaller chunks. So the first percentile, all right, meaning 1% of Americans lie below this value, is simply $0. The 10th percentile is also $0. That means 10% of Americans make $0. Right? If we look at the 20th percentile, it's $6,000. That means 20% of Americans make less than $6,000 each year. That's 1 out of 5 Americans, which is, in my view, a fairly high number, making a pretty low amount of income each year. So we're getting an idea about sort of the distribution of income in the United States by looking at these percentiles. But we might also want to look at the top end. So the 80th percentile is $55,000. What that's telling us is that 80% of Americans make less than $55,000 each year. The 90th percentile is $80,000, which tells us that 90% of Americans make less than $80,000 each year. And then the 99th percentile is $298,000. To put it another way, in order to be in the top 1%, you have to make more than $298,000. To put it even a different way, about 1% of Americans earn more than $298,000. So we're getting an idea of the overall distribution by looking at these percentiles and quartiles. To sort of give you a snapshot overview, to be a member of the top 1%, you have to have an income equal to or greater than $298,000. To be a member of the bottom 1%, you have to have no annual income. So the one point I should emphasize here is that when we're looking at these percentiles, it's the same number of people. There are just as many people in the top 1% as the bottom 1%. The values just differ. So we've covered these other measures of location, the percentiles and quartiles, in addition to the mean, median, and mode. Both of these give you an idea of what the distribution of a set of numerical data really looks like. Having said that, our next step is to actually look at the spread or variation or dispersion of a numerical variable. That's the one key part that we're missing. It's to that we will turn to next.